Howdy folks, over here on the topic of the Private Pilot Airman Certification Standards, and we're going to review, we use the topic of pre-flight preparation, Task G, operations of systems, and specifically electrical system of your aircraft as an example. Now this is mainly going to be a study guide on how to work the ACS, how to work with the ACS, how to study, and how to prepare. I'm not going to give you a complete overview of an electrical system and discuss everything about an electrical system. Just an example how you will organize your study. The main thing to understand is that when you work a study strategy for the ACS, you can get overwhelmed by the volume of it, how much there really is to read, in addition to what you may have already done for your written tests, for your knowledge test. And so now all of a sudden it's so much more. Again, this is not really a complete reference of how to really do this, but this should illustrate how you can go about it and not get overwhelmed and not get buried in different books and chapters. Specifically, in regards to the electrical system, naturally your aircraft pilot's operating handbook may be different, so this is just an example of what one aircraft in Cessna 172 SP might be. You have obviously have to use a little bit of a caution, in how everything is organized in your specific airplane, and kind of study for that and make sure you overview those chapters adequately. The tasks in the ACS are listed by the name of the task. References are given, and yes, you should download those, and you should have them. And it has a knowledge section, a risk management, and a skill section. And then further divided into different sections that are named Private Pilot Airplane. And they'll have, let's say, for pre-flight preparation, G, operations of systems, K, knowledge 1, and so forth. It's very helpful for you to create a page or chapter for yourself, a study chapter for yourself for each one of those line items. The test might be really only about possibly 3 of the sub-elements there, but you don't know which ones they are. You could maybe eliminate water rudders because you're not taking a single engine C test, but most of the others will apply. Risk management will be a chapter, and skills will be a chapter, and all of that creates a bit more than kind of what meets the eye here. So in the electrical systems, for instance, there would be failure to detect systems malfunctions or failures. There would be hopefully you'd write a couple of paragraphs for yourself and remind yourself of how to handle failures, or what could be a possible issue with the electrical system that you might fail to detect, what might help you troubleshoot that correctly. And in the skills section, you are expected to explain and operate at least 3 of the systems. So while some of this will be done during the actual flight, a lot of it will be done during the actual oral quizzing, including using the appropriate checklists. Again, during the flight, you might be asked to troubleshoot a certain system failure. Operations of systems, knowledge, risk management, and skills are the subdivisions there, and well, that's really that way in each of the tasks. So this is nothing new for this one, and once you get familiar with it and know how to study for it and know how to write little paragraphs and little chapters for yourselves, for your study. This will be repeated over and over and over again. Similar with some of the references. In this case, FAA Risk Management Handbook would be the 8083-2. If you're not going for a seaplane rating, then 8083-23 isn't really going to apply to you. But certainly 8083-25, the Pilot's Handbook of Aeronautical Knowledge, you should already have. And of course, your own Pilot's Operating Handbook or Airplane Flight Manual for the airplane that you're going to fly. So we're just picking one segment out of this, the electrical system, as an example. We encourage you to work with examples and scenarios that fit your airplane, things that can go wrong, checklists that do apply. Use your pilot's operating handbook, amplified procedures to prepare for those. Certainly involve your CFI and possibly your mechanic if there's some understanding that's that you have a little bit of a trouble with. Then maybe the mechanic could help out there as well. All the task areas, well, I shouldn't say all, but a lot of the task areas carry over into the flight portion, and your main help there in regards to the flight portion is actually the checklists, and so usually what's written out as a checklist is the absolute minimum of what you need to know about, and so you see electrical failures, you see electrical fires, alternator issues, things like that. And so in case you're wondering, well, what all do I need to know in regards to explain and operate? Well, explain and operate, the operate part would be, straight out of the checklists. Your pilot's operating handbook may be a little different, but generally they are organized in this manner: general limitations, emergency procedures, and so forth. And then one of the chapters will be the airplane systems description. Within the table of contents there, you will then find for the electrical systems some chapters where you could maybe write out a few pages, just some essential knowledge that you think really might be on the test. Your CFI will help you out with that. Most of these don't really go into that much detail to begin with, so they're fairly simple anyway. But some of them are a little bit more in depth, and so you're going to have to decide how deep you're going to want to dive into those chapters. As we discussed, some of those items will be cross-referenced back to the checklist, the emergency checklist, things of that nature. So what are we talking about then? Well, we're talking about going into the amplified procedures and then just grabbing big line items out, like this airplane is equipped with a 28-volt direct current electrical system. So it's a DC system, and it's 28 volts. Once it's working, if it's working, once it's switched on. So the system is powered by a belt-driven 60-amp alternator and a 24-volt battery. Difference between the 24-volt battery and the 28-volt system, then of course allowing for the battery to be charged. And there could be, for your aircraft, a lot more in this chapter, but usually that's right about the beginning of it, and sufficient for the beginning of it all. Well, it gets a little bit more in depth, it gets a little bit more convoluted when we go into electrical schematics, and where people get nervous, a little uptight about it. And the deal is you really don't need to know all the ins and outs. Nobody expects you to put one of these together. Nobody expects you to know everything about it, but you are expected to know the main components of it, and just have a vague idea of some of the smaller components that are in there. In the Cessna aircraft, what's hidden in the power distribution model, or JBox. A bunch of relays here. Relays are basically what works or switches systems. Things are usually activated by relays. If they work in the airplane, they're usually somehow switched or activated by a relay. And that's simply an electromagnetic switch operated by a small electric current that can turn on a much larger or operate a larger electric current. So when you see this schematic here, some smaller bits and pieces, some you'll know, some you might not know, and then ask your CFI, ask your mechanic, and it's pretty much how you eat an elephant, one bite at a time. Right? Just don't get lost in the totality of it. Just use one component at a time. So in our case, the master switch would be one of them. We'd say, well, there's a master switch. What does it look like? Well, it's got an alternator and a battery side. Master switch is a split rocker type switch. It's labeled master. It's on in the up position, off in the down position. The right half of the switch, and this is where it gets interesting, of course, labeled BAT, controls the battery power of the airplane. The left half, labeled ALT, controls the alternator. And when you switch on the aircraft battery master switch during your pre-flight, if you turn on, the engine's not running, this is your pre-flight now, if you turn on both alternator and battery side, and then listen on the side of the cowling near the J box, you could hear some humming, and so you could see once you switch the alternator side off there, you won't hear that humming anymore. And so I guess one question might be, how do you know that that alternator relay is actually working without switching the engine on? I guess possibly something like that might come up. And you have electrical power supply malfunctions that could be for different systems that are installed in your airplane. Very generally, really, this is just about an alternator that is, let's say, malfunctioning, giving an excessive rate of charge to the battery, and pilot response might be to turn the alternator off for that problem. Then turn non-essential equipment off, and then terminate the flight as soon as practical. That response, and the one about low voltage enunciation, where low voltage comes on during the flight, those are typical power supply malfunctions that are listed for something as small as a Cessna 172. Battery, there are different types of batteries. You could get into that, and about servicing batteries, and what the mechanic does to service the battery. Typically, when you're a student pilot, you're not really having to deal with that, but maybe when you're a private pilot or own the aircraft, you might have to deal with that. So we'll talk a little bit about battery, how can it be charged, can it be removed from the aircraft, is there an auxiliary or a ground power plug in the aircraft. Talking about a little bit more about alternators, what makes them work. They're belt driven, and that once that belt goes, well, so goes the alternator. It's not going to be producing any output anymore. For sure, there's be something about the indication system in your electrical system discussion. In our case, in the Cessna 172, we have an ammeter there and a low voltage warning light. That gauge indicates the amount of current in amps from the alternator to the batteries. Let's say it would be like a rate of charge indicator, or if the alternator would not be running, from the battery to the airplane electrical system. So basically, it would be like a load meter. It would tell you how many amps we're using. When the engine's operating, the master switch turn on. Ammeter indicates charging rate applied. If the alternator is not functioning or the electrical load exceeds the output of the alternator, the ammeter indicates the battery discharge rate. Battery being discharged will at some point then lead to the low voltage light coming on, and then gives you a warning that your alternator is not producing adequate output. If that low voltage enunciator finally now does come on, there'll be a checklist for that, and you see there are really no bold print items here, so this is technically really not a memory type checklist. So during the actual flight check, you would, in response to a low voltage enunciation that's being proposed here, well, you just pull out the checklist and then work down the checklist in your particular aircraft in the sequence, in the exact sequence that it's being presented here. The ignition starter system naturally would be part of all of this, because without electricity, they're not a whole lot of fun. The ignition starter, just get into very, very simple terms of how the aircraft is started and what actually makes it happen. That yes, we actually do need a battery for that. Are there alternate ways of starting the engine? Is there like hand propping? Is there an external a plug that could help us with the engine start? Things of that nature. So you would start sort of like at a very broad overview on how it's all working together, and read that chapter, and then just figure out, maybe failure modes, or what to do if a starter or a battery, let's say, would not work. So again, each one of these items here, whether that be power plant and propeller, landing gear, fuel oil, hydraulic, whatever, it all works the same way, and you would actually write down little chapters, little knowledge bits that you want to remember for each one of those. The risk management is probably the most important part of it. This is kind of where we actually work problems that are being presented by the examiner. And so as you're working through each task and knowledge line item, yes, make important points that may come up, but also make sure that once you've divided difficult and busy subjects into smaller areas, that you also make sure that you have this for the knowledge for each task, knowledge, and risk management area. So don't skip those thinking, well, I know now how an electrical system works. Well, that's not really where it ends. We do need to know in the end what truly can be done if there's a failure that occurs, or what could cause a failure, or what could be the result if I ignore a failure, or if I fly an aircraft with a known deficiency in the electrical system, and so forth.